In this example, a manufacturer's production is modeled by the Cobb-Douglas function f of x comma y equals 100x to the 3/4 times y to the 1/4 power, where x represents the units of labor at $150 per hour and y represents the units of capital at $250 per unit. The total cost of labor and capital cannot exceed $50,000, while the manufacturer's production level exceeds 16,000 units. So here, what is our constraint? Okay, since x is in terms of 150 per hour, what we know is that 150 times x plus 250 times y cannot exceed $50,000. So at most, it equals $50,000. But remember, our constraint has to be something equals 0, so we just subtract 100. Has to be something equals 0, so we just subtract 50,000 from both sides. We get 150x plus 250y minus 50,000 equals 0. And so now we can set up our function. We have f of x, y, lambda equals 100x to the 3/4 times y to the 1/4 minus lambda times 150x plus 250y minus 50,000. And so distributing out the lambda, what we get is 100x to the 3/4, or y to the 1/4, minus 150 lambda x minus 250 lambda y plus 50,000 lambda. And now we take our partials. We get fx equals 300 over 4 times x to the minus 1 over 4 times y to the 1/4. Remember, because y here is still a constant, minus 150 lambda. Fy, we get 100 over 4 times x to the 3 over 4 times y to the minus 3 over 4 minus 250 lambda. And then lastly, f lambda, again, is just whatever's in parentheses up here. So we get minus 150x minus 250y plus 50,000. And so again, I'm distributing this negative in here everywhere and then just writing down. And we set all those equal to 0. Okay, given this first equation here, let's solve for lambda. So what we know is 300 over 4 times x to the minus 1 over 4 times y to the 1 over 4 equals 150 lambda. And so now we can divide both sides, and we get lambda equals 1/2 x to the minus 1 over 4 y to the 1 over 4. With that in mind, we can plug lambda into the second equation. We get 100 over 4, or in this case just 25, x to the 3/4, y to the minus 3/4, minus 250 times 1/2, x to the minus 1 over 4, y to the 1 over 4 equals 0. And this will simplify down to 25x minus 125y equals 0. So this tells us that x equals 5y. And now we can plug x equals 5y into this equation here. X equals 5y. We can plug that into our f lambda, and we get minus 150 times 5y minus 250y plus 50,000 equals 0, which tells us that y equals 50. And then, therefore, x must equal 5 times 50, which is 250. Now, the question asked us, will our maximum production exceed 16,000 units? Well, what we can do is just plug 50 and 250 into our f of xy function. So we'll end up with 100 times 250 to the 3/4 times 50 to the 1/4, which is going to be 16,179 units. So yes, our maximum production will exceed 16,000 units. One quick note that I want to make here is this thing right here, this lambda that we found, lambda equals 1/2 x to the minus 1/4, y to the 1/4. Economists refer to the Lagrange multiplier obtained from a production function. They call it the marginal productivity of money. So for instance, in the previous example where x equals 250 and y equals 50, lambda equals 1/2 x to the minus 1/4 y to the 1/4 equals 1/2 times 250 to the minus 1/4 times 50 to the 1/4, which works out to be about 0.334. This means each additional dollar spent on production produces approximately 0.334 additional units, and this can help save time on other computations. So for example, the manufacturer in example 2 now has $70,000 available for labor and capital. What is the maximum number of units that can be produced? Well, we can go and work through the entire problem again and come up with the same answer, or the only thing that's changed is the available money. It went from $50,000 to $70,000. We know that at $50,000 we can produce 16,179 units. Plus, and like we talked about earlier, the Lagrange multiplier, the marginal productivity of money is 0.334, and we can multiply that by $20,000, which is the extra capital that we got from 70,000 minus 50,000 is 20,000. And this here will work out to be about 23,400. So simply by increasing our capital by $20,000, we can increase our production from 16,000 to 23,000 units. And we don't have to go through the whole Lagrange multiplier process again.